Okay, so here's my spider interface. Let's make a new one and let's go from there. Okay, so let's see how to make a simple plot. Let's just plot something as simple as sine of t. Okay, how would you do that? So we want something on the x-axis so that we can make sine as a function of that variable. So it's the independent variable. Now, this is available in NumPy, so you need to import that. Let me import that in just a bit. But this just tells that you want to have t from 0 to 6 in 50 different splits. So 50 points from 0 to 6. So I need to import NumPy as np, and then I can use this t equals np dot linspace. Now, by default, Python does not have sine of t. So you need to use the NumPy again. So let's say y1 equals NumPy sine of t. So now we get y1 storing the value of sine of t. Let's say y2 is an NumPy cosine of t. And let's save it, let's call it plots dot py. Okay, and in order to plot, the little bit work you need to do to plot, again, plot by itself is not available in Python. So you need another package, which is called matplotlib. So import matplotlib dot pyplot is the particular package which we are interested in. So I import matplotlib.pyplot as plt. So I can now use plt to make the plots. So figure 1, this first line is not mandatory, but I'll put it because I want to create multiple plots. plt plot t, independent variables, y1, dependent variables. And if you want a particular line type or line color, you can actually use this R, which stands for red. You can use black, green, G, K, so on. Okay, it's very similar to MATLAB, this part, except that you need to include the matplotlib. So we'll run this. And so you see that in plots, it creates these plots. And that's probably not ideal. You want the plot to show up right in your screen. And so there's one setting you need to take care of. If you want that to show up, you need to go to, let's see, Tools, Preferences, IPython console, Graphics, and then change this inline plots to automatic. So you do it once and it just stays. Now let's run this, and then you'll see that the plot popping up on screen. Oh. String. You see? Oh, there it is. And let me close that. Yeah, there it is. So that's the plot of clearly sine of x. You can also, if you want another plot, just say plot t comma y2. This is the cosine of t within a different color. I don't know, you want blue with a different line type. That would be put a plot for cosine. And when you do this, you'll see two plots, but we want to actually name them. So what we do is use legend. So plt.legend. The first one is sine, which is y1. The second one is cosine. And sometimes this is helpful because it gives you hints. You can turn it off if you want. So legend, and then we say we want to say something on the x and y axis, label the x and y axis. So x label t, y label, I just call it y. And if you want a title, you can say title plot of sine cosine as a function of x or t. Okay, so let's run this. So you have two lines, one for sine, one cosine, and then you can see that there's a different line type for the cosine dash dot. So that's how you do a simple plot in Python. Now, if you want this to close, you can say plt.close. So it actually popped up and then closed. Maybe you want it to stay for some time. So you can actually use plt.pause. I don't know, let's say 2 seconds. So it'll stay on for 2 seconds and close. Okay. If you want to make another plot for, let's say, only sine cosine, you can actually continue this by saying plt.figure2 and then write your code here. Okay, so that way you can generate 2 plots. We can actually do this. Let's just do one of these plots. I'm just going to copy paste. Okay, so it actually it's just waiting for this. So you're better off saying plt pause, plt close, and then the second one. So now if you run this, hopefully we'll all do what we wanted to. So stays 2 seconds, closes. And then because I did not put the pause here, it's probably that's the reason why it just popped up and closed. Closed and opened up. Okay, so it's pretty much like if you have, it's basically trying things out, seeing errors or seeing the effects of what you wrote and then trying to understand from the code you write, and that's pretty much how you'll do this. Okay, so that's the plot. Now we'll get to the most interesting part, is how to do animation. So let's open a new one. By the way, did you guys see Blackboard? I posted the code, so you don't have to be taking notes or anything. It's really hard to take notes for code, so you can just use that and run that on your machine. Okay, let me show you how to make animations. Okay, here's our first animation. So what I'll do is, I'll plot, let's say, cosine, and I'll show a bead sliding along the cosine. Okay, that's my goal. And so I can reuse a lot of the code I just wrote down. Since I already have the cosine, I'm just going to pluck it from here. So copy this, and we call that animation. Okay, we don't need this. Let's call this y. And the first step is to actually plot the functions. Let's just plot it. Okay, so that's something we've done before. Now let's think of how do we cause, let's say, a bead or a red dot to go along the cosine. Okay, that'll be our first animation. Okay, so what we want is, it's basically like a flip book. You make pictures of the bead in different places, and then you just show that that flip book, you turn it at a certain speed, and you'll see these put together, and it looks like the bead is moving, but it's actually different pictures of the bead in different positions, which you show in succession. So for that, what I need to do is I need to write a for loop, which will basically show those pictures and create those pictures. Okay, so here's how I'll do it. First, I'll have the for condition, which basically runs a loop. This basically tells you that I want to run I from 1 to range of len of t, which means that you go from 0, it'll go from 0 to 49 because there are 50 points. Then I want to do is I want to say plt.plot P of I. Okay, so that's just a point yi, where I is an index. Let me put a color to it, green. Um, since it's a bead, you put a marker. Say this is O. And here at this point, it looks like I could extend this. But if you want to write on the new line and not have to extend the screen, then you can actually put a backslash. So it tells, put a backslash and enter. It's completing something. Let me just enter first, okay? Put a backslash. So this tells it that you can just have to continue reading it. If you don't put a backslash, it'll give you an error. So marker, this is incorrect, should be O. And then I need to say marker size. You can put whatever you want. Let's just take 10. It's a number, so you just don't put a quotes. Okay, so you run that in the loop. And I think that's it. So let's just try to run this. Okay, so what it did, it basically did. You just put the dots there. Now, if you wanted to show slowly, then what you want to do is you want to put a pause between those two pictures, like the flip book, there's a pause between those different pages. So what you can do is you can use, there is a pause in PLT. And this is in seconds. So I'm just going to put 0 to seconds, which is 200 milliseconds, sorry, 20 milliseconds. So you see that shows, but then this is not what we want. We want the beat to show and then the previous beat to be deleted. So what we can do is we can actually, we would need some, we need to define the plot this way. This basically puts this object, this function into this variable TMP, because now I'm going to take this TMP or temporary variable and just delete it. Will delete that. So if I now run this, you can see that it looks like an animation. Now, if you want this to stop from plotting it, then or stop the figure, then you just go outside the for loop and say plt.close. So it goes and stops. If you want to slow this down, you increase the pause. So let's make it 0.2. Another way of making it slower is to put more points. So if you have 0.02 and then you increase this to, it's 1,000 points. This will also slow it down because now you have too many points. It also shows it going more slowly because of the sheer number of points. So you have two ways to play with this, either the pause or the number of points. Now, when you want this to look realistic, you probably want to play with it that looks realistic. Now, there's no realism here because there's no physics which makes this bead move. But if something is falling under gravity, then if you want it to look realistic, then you don't want it to show it in slow motion. So you might want to play with the pause. And we'll get to an example where we're doing a project that stopped. So let me change this back to the okay, so that is how you do an animation. Just the same idea of the flipbook idea, we can extend it. Now, in this course, we'll be using more complicated, we want to create more complicated things like objects, right? And objects can be represented with, say, circles, triangles, and so on. If you want to go beyond that, that's where we'll use Coppelia Sim. So how do we draw circles and rectangles and so on? So I'll show you how to do that. And I think once we have that, we are all set to do more complicated animations in Python, which will aid us in writing code. So here is a more complicated animation. What I'm going to do is, you can actually make a movie. So I'm just going to draw a yellow dot. Let's think of that as like a sun, and then it goes up and down. It's hidden behind a rectangular block, a brown colored block. So it just looks like the sun is rising and then setting down. Okay, how do you do that? So again, we'll need those two things, NumPy and Matplotlib. Okay, we would need to create, well, pig equals plt.figure. This is where I will draw everything. And now let's start writing code, which will make us draw things. So first of all, what I'll do is I'll draw a rectangular box. Okay. So for that, I need a patch. Okay, this is the name. You will use something in the matplotlib called rectangle. This is a function inside matplotlib. Now, if you see this, it actually tells you how to write this function. It says x, y. So the x, y coordinates of the rectangle. It actually gives you one of the corners of the rectangle. It's actually the bottom left corner. Give it the width. Okay, give it the width and the height. Okay, and then there are some other things which is in the kwargs, which basically tells you about the color and so on. You could also rotate it. You can see that the rotation point and angle. So if you give that x, y is the same as the corner, and you say rotate by 30 degrees, it's actually rotated. We can actually try that later on. So let's put it at 0, 0. That's going to be my corner. So 0, 0. I want the length to be, or the width to be 2, height to be 1. So it's a rectangle. And of course, you can make a square by making length equals height. I want it to be, say, brown. Okay, let me go to the new line. So I'll figure out to avoid this. So go here and color brown. And then this argument, which I'm going to show you, is there's the opaqueness of this. So, okay, now if you run this, this actually will not do anything. It just creates a figure, but doesn't really plot it. It requires another command to show it. It's called, you need to add the patch. Now there's some details which I got from looking at an example. You need to first use this command, subplot. Okay, I did not know about this till I looked at an example. So there are some intricacies which are not very obvious. Like, why do you have to do ax equals fig.add subplot? That's how the program is written. So once you have this, then you can use ax to add the patch. The patch is the rectangle. We'll save this. Let's call that animation. Let's see. Okay, so what you see here is it actually created a box, 0, 0, and doesn't really look like a rectangle. It looks like a square, right? x1, 0 for the x and 0, 1 for the y. So it's not a square. That's because by default it chooses the size of the canvas, the figure, to be of dimensions 1, 1. So what we can do is we can actually set the axis. Let's set the axis. plt.xlim 0, 2. This is saying that the x-axis should be 0 to 2. plt.ylim 0, 2. And now if you run this, it actually shows us the box, sorry, the rectangle as it should be. Okay, x-axis 2, y-axis 2. Okay, any questions? Okay, so we've got that. Now let's work on the other part. Let us draw a circle. Before that, maybe I should show you how to draw a line too. Just something useful. We may not need this here, but let me just show you how would draw a line. So patch line. The command is plt.line. I'll just draw a line over that rectangle to show the horizon. So line 2D. And so it'll tell you how to use this x data, y data. So you need the x data and the y data of the line. So this is basically telling you the line has two coordinates. You need to give the x data for the one endpoint, x data for the other endpoint, and the y data for one endpoint, y data for the other endpoint. So here what I'm going to do is I'm going to draw a line which is sitting right on top of the rectangle. So if you remember, the rectangle was of dimensions 2 and 1 on the y-axis. So this line should sit at So I want it exactly on top. So the y-axis is constant. So I can put that first. 1, 1. And the x-axis should stretch on top from 0 to 2, because 2 was the length. So 0, 2. Okay, now I can give few things which will make it look good. I'm going to make it slightly big. So line width should be 5. And then I want to give it a color. So color equals black. Okay, and remember that this will not show up unless I use, seems to be an error here. Okay, it's fine. AX equals, for this it will be AX equals, sorry, AX dot add line. And then I give the name, match line, and now if we run this syntax, what's that? Comma right here. Okay, so that's the line which is on top. Okay, now I'm going to draw a circle. That's my son. So what I'm going to do is create a new patch. Patch circle equals plt dot circle. Okay, now it's telling you need to give the x comma y coordinates of the circle and then the radius. So the x coordinate, I'm just going to put it so that it's visible. So we know that I think x-axis. So since this is 2, if I put x as 1 and y, the height was about 1, so I'll put it at, let's say 2. What happens? And then the radius was 0.25, and then I need to give a color was, say, yellow. Let me just make it 1 because 2 I think is the edge. And then AX dot add patch. Okay, now it looks, well, it looks like it created the circle, but it doesn't really look like a circle. It's actually an ellipse. And that's because of my axis. You see that the x-axis are stretched compared to the y-axis. And so one way of fixing this is to ensure that and this is something that you always have to do, which is ensure that the x and y-axis have the same aspect ratio. For that, what we do is there's a command in here. It's called plt.gca.set. Now, these things are really hard to find if you are trying to search the documentation. The best way to get this is to actually search. That's what I did. How do you set the aspect ratio to be equal? And then I just got the command for matplotlib, and that's how I know about it. So now it looks good. Okay, let's move it slightly up, maybe 1.5. Okay, that looks good. Now, the last step is to do the animation. I'm going to make the circle go down and up. That's the goal. So for that, I need to create the flip book. So I need coordinates for the center of the circle. So from wherever it is, I wanted to get it from, let's say, the y is 1.5. I want it to go, I don't know, maybe to 0.5 and maybe back to 1.5. That's what I'll do. Actually, I'm thinking maybe I should start this way. Let me just start it. There an error. It's here. Best way of dealing with this today. we put that command, which pauses and then closes. Okay, I don't have to keep doing this. I don't know why that's happening. Anyway, that shouldn't stop us. So you saw that the circle was inside, and I'm just going to make it go up and down. So here's what I do is I create a y, which basically, let's say y equals np.linspace. I know I'm starting from 0.5. I need to go all the way to 1.5, and I want 30 points. Okay, so I need to go from, well, this will be a for loop now. Instead of putting it right at 0.5, I want the y coordinate to be dictated by that linspace. So what I'll do is I create a for loop here. I equals, for I in range, len y. Okay. All this needs to be indented. Okay, this should be yi. And remember that it needs to basically, I need to, in order to create that image, I need to redraw it every single time. So I need to remove that. So p patch circle dot remove. Okay, so that'll remove it. But before that, I also need to introduce that flip book concept. So plt dot pause 0.2. Okay, so I have the patch, I have the pause. Let's run this. Okay, so it looks like it's working, but I really don't want to show the yellow dot in front of the green. It's supposed to show a sunrise, sunset. So what I'm going to do is, one way of fixing that is to ensure that you always draw the patch for the rectangle after, or then the line after the patch for the circle, right? That will ensure that the circle is behind. So what I do here is just take this, put it here. Okay, so now the circle is plotted first, then the rectangle, then the line. It looks it's going up. And then it disappears. You could fix that actually by ensuring that for the last draw, it doesn't really erase it. Okay, because here by default just erases it. Now you could actually change this to go up and down by adding this if you want. Let's just do it. So this is for going up. We also want it to go down. So y2 equals np.linspace 1.5 to 0.5, let's say 40. And now what we need to do, so y1 basically takes it up the circle, y2 will take it down. We just need to put it all together. So I will join them. So the command to join two linspaces would be np.concatenate. Okay, and then it tells you what you need to do. You just have to say y1, y1, y2. You just be mindful about the brackets, two brackets. Okay, so that we got that. So we just have to now go for it. Okay, it goes up. And goes down. You can play with the pause or the linspace to figure out the speed. Okay, so that's an introduction to Python and animations. And